Right, this Harrison 140 lathe is equipped with a 36 speed metric gearbox. You can cut any metric thread you want with it. The one we're looking for is 1.5. If we look along here, it says for the change wheels for lengths 2, 3 and 4, which is 2, 3 and 4. They're the change wheels you need. That's what I've got. I've got a 25, 100 and an 80. It shows how to set the levers up. 1.5, you look along here. 1.5. Both those two face forward, and that's the magic one that a lot of these lathes haven't got. The right hand lever, that faces that way as well. So that way, that way, that way. And you put this into the little dead end below the 1.5. So in theory that now was set up to cut 1.5 thread to the inch. We'll just check 1.5. Both them levers forward, right hand lever forward, and that is in the 1.5 position. What I'll do, I'll set the tool up and I'll do a dummy run with it barely touching the surface, just to mark the material before I commit myself. Right, this is the screw cutting tip we're going to use. It's a commercial metric phone threading tip. It's a proper tip for cutting metric threads. It's set up on centre height. The other thing that needs to be done is set up square to the job, so it's going to cut an even thread. The easiest way to do it is to use that face there against the shoulder, either the chuck, but I can use that shoulder there because that shoulder is at 90 degrees to the shaft. Simply bring it along, loosen off the tool post so it can pivot, and touch it against the face, so we've got a full contact area, which is there. Tighten up your tool post. That means the tool is now set at 90 degrees to the job. I've also got the compound slide set to the right angle. One easy way to check is if you look at the angle of the tool. Right, this is important. That tool in there is a metric tool. It's at 60 degrees, which is 30 degrees aside. So if I put a straight edge, imaginary straight edge, anyway, you can see the angle that's making there. If you look along the straight edge, it's the same angle that the compound slide set to. 30 degrees there, and that's 30 degrees running straight through the axis of the compound slide. So when I advance that, it's going to bring that in at the right angle to cut the thread. Trust me, it will. I've got the lathe running at 65 RPM. It'll go a bit slower. That's quite a nice speed to screw cut at. Everything's set up. What I've done, I've withdrawn the tool well away from the job, and I'm going to engage the half nuts just to make sure it's going the right way, which it is. It's going towards the chuck. You don't want to have it lean close to the job and engage it and find the bastard goes the wrong way. This being the metric lathe, it's got a thread indicator, and basically on a 125 thread I can drop the nut in anywhere on any line, but what I'll do, I'll use a numbered line. So I'll advance the top side in, advance the cross side in until it's just touching, and I'll zero it there. I'll also zero the compound slide. We're going to put the cut on with the compound slide. I've put some nice purple dye on the job because it looks sexy and nice, and we'll be able to get a good indication if it's cut the right thread or not. Right, so we'll put that into zero. I'll wait until it comes round to a whole line, and I'll engage the half nuts, and that'll put a very light cut on just to verify we're cutting 1.5 threads to the inch. I've only got one chance with this. I've got to get it right. I can't get into that joint. Right there, engaged. We're scratching the surface, it looks good, so we'll let that thread cut to the end. Right, we're disengaged. Right, we'll check that fit. I can actually see better through the camera than I can with my glasses on. Right, you can see there. That's cutting a 1.5 thread. I'll leave the camera where it is and put another cut on. So basically it's a cross slide back into 0, which is there. We'll put the cut on with a compound slide. Yeah, we'll start it up. Plenty of lube on. We're scratching the same lines, which is always good, but you don't want to double start thread. Right, so we're weighing our cross slide out, back, cross slide back into 0, cut on the compound slide, a little bit of oil, watching for our thread dedicator to come around, which just seems to take ages. It's engaged. Looking quite nicely. You've got to adopt the same procedure every time you do this. It's no good changing halfway through because you'll make a mistake. It's a good way to focus the main screw cutting. If you do it all the time, it's probably second nature, but I do it possibly once a week, if that. It's something I quite enjoy doing. Now will be an excellent time to have a cigarette, but we don't play those games anymore. I'll take another cut on the same setting, like a spring cut, just to take any strange enough spring out of the job, any flex out of the job. Now it's still putting a decent cut on. I've put no cut on at all. Cutting a nice thread. The thing with angling the tool is it's only cutting on the front part of the thread. If you put the tool straight in, you're cutting on both sides and puts a big heavy cut on, puts a lot of strain on the tool. That's when you end up breaking tools. When you get lads that do this for a living, they would screw cut this at 300 or 400 RPM. Adam Booth here, Bob, he's a prime example. High speed screw cutting. Right, it's time to try the nut on. Go there now. One more cut of the same setting should do it. A little bit tight. Another sprint cut, just about there. Bastard. Right, this looks like the dog's bollocks now. That's nice. When it gets onto the nail lock. That'll do for me. Nice thread, nice and tight. Do a shaky on it. I'm just going to put a tool in there and just put a little bit more radius on that inside edge, and that's the job done. Oh, what, Johnny? Bell end you. There you go. Certainly well worth doing repair. And if the customer can get his car back, it's not going to cost him a fortune. It saves having a car stuck on my ramp all week while I wait for a replacement part. I'm going to try doing a voiceover on this particular part of the video. You'll have to bear with us until I get a better microphone and try and get the recording levels sorted out. This is one of a pair of drive chains that drive the rear axle on this 1929 Sentinel DG8 steam wagon. The chains are driven from a gearbox which is equipped with a lockable differential to give better traction in adverse conditions. The chain is joined by a split link, very similar to a bicycle chain, but on a much larger scale. Once the chain's been split, the split link is wired back into position so it won't be lost. You can't just go down to the shop and buy a spare split link for your Sentinel steam wagon. The square aluminium box you can see to my right with a rod going to the centre of the sprocket is a mechanical lubricator. This pumps steam oil into the cylinders of the engine. This is all proper old school engineering. Compared to the modern vehicles I work on all the time, it makes a much welcome change. This is Richard, the owner of the wagon. Richard's removing the seed-in studs from the base of the inner chimney. Once we get the inner chimney off, we'll be able to gain access to the blast pipe. Due to the corrosive nature of the coal smoke, some of the studs and nuts are badly sealed in. These will be replaced with stainless steel studs and mild steel nuts. Some people think this is cheating because they didn't use stainless steel when the wagon was built. I can assure you, if they had stainless steel, they would have used it.
This is really what stainless steel strips are made. Aye. And steel nuts. Brilliant, good combination.
The bottom hole in the square plate that Richard's removing is where the exhaust steam exits up the chimney. This is called a blast pipe. It's what gives the steam engine its characteristic chuff chuff. The exhaust blast goes up the chimney and helps to draw the fire. The wagon has been well down on performance this year. Once we get the blast pipe removed from the base of the chimney, we'll find out one reason why. The hole in the top of the blast pipe where the exhaust steam exits up the chimney should read 1 1/16 of an inch in diameter. It's actually reading 1.5 inches. This will have the effect of slowing down the blast up the chimney. The actual blast nozzle is a steel insert screwed into the cast iron manifold. various sizes are going to be made so the boiler performance can be optimised. As you can see, everything on the wagon is very substantially made. I've quite enjoyed editing this little bit of video. I don't know what you think of the voiceover. If you can give us your opinion. I'll try and get a better microphone. The situation I was filming in, it was that windy and that noisy, there's no way I could record voices as I was doing it. As usual, I'd like to thank everybody for watching my channel, for clicking the like button. But a special thanks to everybody who sent in well wishes towards my wife Deb and my father Ed. Thanks very much, it is really appreciated.